3.3 log functions. It's your first 3.3 video. We'll do another one on graphing later. So for VICs, or your very important concepts, we have a lot of information. So log functions and exponential functions are inverses of each other. So if you have log base 2 of x, that's the inverse of 2 to the x. And if you have ln x, that's the inverse of e to the x. Ln stands for the natural log. And if there's a log of x, it always has base 10 unless it's stated. So if there's no number here, that's going to be log base 10. If there is a number, it's log base whatever number is given to you. So switching from logs to exponentials, I like to think of it as a loop that goes around like this circle. So you have log base 3 of x equals 4. So when you rewrite it into exponential form, you start at the base. So the base stays the same. It was 3. It still is 3. You raise it to this power of 4 on the other side of your equal sign and set that equal to x. So log base 3 of x equals 4 changes into 3 to the 4th equals x. And from there, you can solve for x. If you're going the reverse and going from exponential to log, and I have 2 to the x equals 4, again, my base is going to always stay the same. So I have 2 as my base here in exponential form. I'm going to have 2 as my base here in log form. So I have log base 2 of 4, so again I go across the equal sign to 4, equals x. So we have a lot of examples for you. This set of examples has a lot to do with the rules that you have in your notes packet on logs and ln's and different things that are true about them. So log base 2 of 8, you can rewrite 8 as 2 to the 3rd. So 2 to the 3rd is equal to 8, so you can rewrite them. And now you have log base 2 of 2, and you learn that those cancel out. So you're just left with this exponent of 3. So log base 2 of 8 is equal to 3. If I have log of the square root of 10, I know when there's no base, it's really base 10. So log can be written as log base 10. And I know that if I have the square root as an exponent, it's equal to 1/2. So I rewrote log radical 10 as log base 10 of 10 to the 1/2. And again, I have this that cancels out log base 10 and 10. So my answer is going to be 1/2. And last, I have e to the ln of 5. And because e and ln are inverses, they cancel out right here. And I'm just left with 5 as my answer. We're going to solve these for x because you'll have a variable in every single one of them. So log base 5 of x equals 3. I'm going to rewrite this as 5 to the 3rd equals x. And 5 to the 3rd is 5 times 5 times 5, which gives me 125. Log base 2 of the cubed root of 16 equals x. I have 2 to the x equals the cubed root of 16. And I wrote the cubed root of 16 as 16 to the 1/3. Because now I know my answer is going to be a fraction over 3 because of my 1/3. And I have to think of 2 to the what power is going to give me 16. So I know 2 to the 4th gives me that 16, but because it's in the cubed root, I need 4 over 3 to take care of every piece of that. And last example is ln of 1 equals x, and because ln and e are inverses of each other, when I rewrite this, I can rewrite this as e to the x equals 1. And I know that any number raised to the 0 power is always 1, so this has to be 0 in order to equal 1. So for my last answer, I have x equals 0.